Good afternoon, everybody. Thank you for coming again, and I would like to welcome you again for the Lochana speech. Right? We all know that we have awarded Lochana prestigious award from Wayamba University, Best School Inventor 2016. Lochana has done some work in medical research, and he was recognized by Intel and Qatar Research Foundation, and he's going to share his ideas about his research, as well as he's going to share his experience, how he has done these activities, and he's going to do a discussion-like part also at the end, so cooperate with him. And with that, I would like to invite Lochana Pumantha to address the gathering. Over to you, Lochana.
Okay. Good morning, everyone, and ladies and gentlemen, and dear students. Once again, good morning. My name is Lochana Pumantha Fernando. I'm from Lanka Central College. Firstly, give me a bit of time because to introduce that who am I, and just please give me just a bit of time to what I have done, what is my research. Please give me a bit of time for that. Okay. So my research topic is anti-proliferative and apoptotic effects of ellagic acid functionalized iron oxide nanoparticles on chemo-resistant endometrial cancer cells. My teacher in charge is Miss Nadia Fernando. She is the science teacher of this my school, and my field is cancer biology. So first in my introduction, the cancer. What is the cancer? What do you think about that? Cancer is the genetically mutated cells than the normal cells. When I'm talking about the normal cells and cancer cells, the phenotype is same, but the genetically difficult because of the DNA or RNA. The most of DNA has mutated by lots of reasons. So UV rays and lots of chemicals, such of things. And if it's having a gene after mutated, the function of the gene is difficult. If I'm talking about such of function, as an example, the division of the cell is doing quickly. What's the reason? Do you know the cell express these genes? If it is responsibility getting to the express, the division of the cancer cells is increasing the very high. The reason for that, the reason is finding at the moment also. I also don't know that about what is the reason. So, what I'm looking for endometrial cancer, so what is the reason for that? The endometrial cancer is some cells after mutated is growing on and into the endometrium tissue of the womb is we can call as endometrial cancer. Okay, so but at the new generation, the cancer is being resistant. What's the reason? Because chemotherapy. We are getting higher doses during the huge time. Cells are analyzing that. So what's the reason? Because cells is having the communicator systems and chemical systems. Lots of are. So therefore, after analyzing that, cells are resistant. They are developing a resistance mechanisms themselves. After that, in the new generation, scientists are developing and they want to identify new peptides, new phytochemicals to develop the anti-cancer drugs to kill the cancer cells. How? To destroy the anti-cancer mechanisms. In this my research, I just also wanted to do that. Therefore, I use the iron oxide nanoparticle. I just wanted to develop a nanoparticle drug. What is a nanoparticle drug? What's the scale of the nano? Do you know that? Yeah, I will tell about that. Nanometer, since 1 to 100, the scale is we are using to developing something, we can call as the nano something. In this my research, I use the iron oxide nanoparticles, the magnetite iron oxide nanoparticles. Because I use the magnetite iron oxide nanoparticle, because by using the iron oxide nanoparticles, I could be to drug delivery into the cells. And by using that, I could be to increasing the efficacy of the drug, because cancer cell is producing the lots of chemicals and enzymes to destroy that chemicals, and therefore I wanted to stop that by using nanotechnology. Okay, so therefore I use the iron oxide nanoparticles. I use that as my phytochemical ellagic acid. Ellagic acid I functionalize with the iron oxide nanoparticles. After that, these nanocomposites I use to treat the cancer cells. As my cancer cell line, I use the AN3CA cancer cells, because which is the chemoendocrine resistance endometrial cancer cells. This is resistance. I purchased that and I cultures here, there, my lab. After that, I just wanted to analyzing how cancer cells is killing. What are the mechanisms? What I can do? So, endometrial cancer. As an endometrial cancer, lots of women is suffering thing. Because of that, is increasing the family problems and pregnancy problems, and therefore some families has broken, some problems increasing and social, and therefore some students cannot to get a very big and very good education. Lots of problems are increasing because of this cancer. So I just wanted to do something for that. So after that, after developing my nanocomposites, I use the lots of mechanisms, lots of methodologies to evaluate the anti-carcinogenic effects. Firstly, to synthesize the iron oxide nanoparticles, I use the co-precipitation method. After synthesizing the iron oxide nanoparticles, I functionalize the ellagic acid onto the iron oxide nanoparticle surface. After that, to characterize that, I use the FTIR SS and transmission electron microscopy SS. I use that. So after evaluating that, I identified the iron oxide nanoparticles has been functionalized onto the ellagic acid by using the OH bonds. The OH bonds. After that, identification of that facts, I wanted to understand the mechanism, how these iron oxide nanoparticles go into the cells. To evaluate that, I used the cell morphological assays and SRB assays and fluorescence microscopy assays. By using these assays, after getting the good results, I identified these cancer cells is killing by using the apoptosis mechanism. Apoptosis. If I talking about the other name for that, programmed cell death. By using, a lot of scientists are using the apoptosis mechanism to kill the cancer cells of the chemotherapy. I just also wanted to do that. So, after identification is the mechanism, I just wanted to evaluate further how apoptosis mechanism is increasing. What are the facts is having in the cells? What are the genomic facts? We are calling to that genotype. Genotype. We are studying under the genotype. While doing these studies, I identified after treatment of the iron oxide nanoparticles, the P53 tumor suppressor gene is increasing by the 4-fold after treatment, and also pro-apoptotic genes and some of enzymes like that caspase 3, caspase 7. I think maybe you know. They also increasing after treatment by 2-fold and 4-fold. By using those mechanisms, cancer is killing. That's the reason. By using these mechanisms, P53 and caspase 3 and 7 pro-apoptotic genes, by using those I could be to target the resistance mechanism which I have in the cells. That's the thing I got from my study. There is having a lot of mechanisms how I am have done. So lot of essays are having on that, and so you can read it. So now I'm telling that who am I and how I came onto this stage and what are my feelings I have got. I think so. Some of idea is having about my research on in your brain, but I'm just a student. Please think about that, because when just I'm coming on this stage, I was so happy, pleasure, but bit of nerves. Okay, just understand that. If I'm talking about me, once again, if I'm talking about my name is Lochana Fernando. My mother and father is not the doctors or engineers or like these things. My mother is housewife and my father is just a driver. But I could be to do like this thing. How I did. I think nature also helped me. I'm coming to my mother Senanayaka from my village school. After that, then Senanayaka, my college, my mother, which was a paradise for the science. Therefore, Mother Senanayaka increased my science knowledge and how we are thinking creativity. Because in the Sri Lanka, we are the students, school students, we are learning the knowledge that created by you are the creators, the knowledge. We are the who we are the students, we are learning. By learning, just like you, my dear sisters and brothers, you are creating the knowledge by doing what? Researchers. Actually, I could get the big opportunity to do a very huge research about the cancer. In the Sri Lanka, to do just like this research is very difficult. I know that about, because which is not my first research. My first research was the developing a peptide to inhibit the dengue virus by using murine model. I decided to do this my research in the Medical Research Institute, but I couldn't because I had a lot of barriers. I couldn't to destroy that. That's the reason Sri Lanka is sometimes, I must tell it that. I don't know because which is not the paradise actually if I talking about. So some blame me, some how is I'm talking but however I met the good scientists, lots of, because I came just like of this stage. I could to go to the United States for the mini Nobel competition. This is this medal, this is gold plated. Because I do this my research to get this and to go United States and to do a best research for the Sri Lanka. Actually I like it. My mother and my father is not the scientist. I think maybe yours also same. Don't think about that. You can do it, my dear sisters and brothers. I know we are having bit of facilities, but using those do a best thing. Results might be negative or positive, but don't think about it. Negative or positive is a result. If you do something, do that from the bottom and to the top. Never quit and never stop. You can do it. So, if I could to do like this research, not just alone, because my teacher in charge, she and my sir, both are inside you, and my scientists, they are not there. I must to remind my supervisors, Professor Kamini Tennakon Madam, and Dr. Samira Samarakon Sir, and Dr. Rohini Silva Madam, and Dr. Inokasi Pereira. They have helped me lots of. I haven't a grant. How I pay for my essays? I haven't money because my mother and parents are not the big man from the rich if I'm talking. But they help me because I wanted to, actually from my heart I wanted to do that, and therefore they saw it, I think, and I waited lots of times. So however I could become like of this stage with a very big respectability and with lots of lovely I could become. And finally I will tell you can do it, my dear sisters and brothers. If you need something to do, tell your professor or doctor and they will help you, sure, because you are having perfect lecturers. I know that because actually I know that you can do it, and you are having the big huge of facilities because I have seen you can do it. Actually some facilities are not in the University of Colombo, so you can do it. You start, if you could please start also about the molecular biology, like this is sisters, you can do it. Finally, thank you very much, sir and madam, for calling me to this occasion, Actually, I was so happy. I haven't to tell anything about that. Actually, very nice. You have organized very nicely. Actually, very, very, very cool. So, actually, I haven't told them because my feeling is changing. But I must tell to you. You can do it. Okay, thank you very much finally for all of you. Thank you so much.
If you have any questions, you can raise, and Lochana would answer you. Please, few questions.
Yeah, of course. Of course, madam. National Science Foundation, I remember when I am studying at the grade 10, National Science Foundation called to our school to come there for workshop about researchers, and therefore I went there. That was the first time I went to Colombo. So, which was the very cool because lots of scientists and doctors, professors was there. Therefore, I call with them. They ask me, and they teaches us how we are doing researchers. What is the scientific method? They learn us day by day, step by step. They improve us. Therefore, by using that knowledge, I learned to think as creatively. When I am going to my home and come back, I thought about that. How I am doing research? What is my topic? What I must to do? How I am do that? How I am finding my knowledge? Because in that time I was that grade 10 maybe. So, but I wanted to do a cancer research. Actually, I wanted to do that. And how I am finding my knowledge. And knowledge is the important thing if I am doing a very good research. And communication, how I am communication with the scientists, how I am do that, and how I am finding the best scientists or doctors or someone for suitable my research, and how I find that. National Science Foundation has done great work for make up me. Actually, National Science Foundation had that. Okay. Okay, madam. Thank you.
Any other questions? I have one technical question. I don't know. Probably, with compared to our body,
Yeah.
as well as with in vivo assays,
Yeah.
how about the cancer cell growth rate? Is it different or same?
Different.
Which is high?
Please describe that about what you need, sir. No, please describe. If I could.
Say, I'm a cancer patient.
Yeah.
So I have a cancer somewhere.
Yeah.
So the growth rate of my cancer cells in my body,
Yeah.
as well as if you grow it outside in vivo assay, is it going to have same rate?
So outside we could not to do in vivo assay. If we are doing a yeah, sure. From by using our cells. Yeah, we are things my cancer is having in the breast, in the lump. Okay, so I'm getting a needle and getting the cells, we are calling to that as a FNAC test. FNAC test in the medical sector. So after that, by using the blood, after getting the blood, we are culture that. I think that centrifugations. After by using those methods, we are isolating the lump in breast cancer cells, maybe breast or normal. After that, we are culture that in the 96 well plate. After that, to evaluate the cancer or normal, we are having the mediums to drop that, just like DMEM medium or RIMI 1640 medium. We are culturing the cells in that mediums. After culturing, we are having the lots of assays to evaluate that, just like MTT or SRB, just like assays we are having. And by using those, we could be to do that, sir.
All right. Thank you very much, and I appreciate you coming here, Lord.
Yeah, sure.
Thank you very much. Thank you very much. Please give him a loud round of applause.
Excuse me if I had any fault, please. So sorry for that.